Section 9.2.33. The data shown below represent the repair costs for a low-impact collision in a simple random sample of mini and micro vehicles. Complete parts A through D below. So, we want to draw a normal probability plot to determine if it is reasonable to conclude the data come from a population that is normally distributed. Okay, so what we want to do is we're going to open up our data in StatCrunch and then draw a QQ plot. So we're going to open up our data in the StatCrunch. Okay, and then what we're going to do, let's go ahead and open this up here. Okay, so we're going to go to Graph and go to QQ plot. We're going to select our column. We're going to make sure that the correlation statistic is included. We want to make sure that the normal quantiles are on the y-axis. And we also want to include the horizontal and vertical lines. So when we choose from our multiple choice, we can see where those points are supposed to be. So we're going to go ahead and compute that. And so therefore, there is our normal quantile plot. Okay, so what we want to do is we want to compare the correlation coefficient, and we want to see if that is going to be greater than the critical value. Okay, so we know that R is 0.959, and the critical value, we need to look at our chart where n is equal to, in this case here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values. So when n is equal to 10. So coming down here, when n is equal to 10, what is our critical value? The critical values for the normal probability plots is 0.918. So we get 0.918. So therefore, that is true. So therefore, we can say that since the correlation between the expected z-scores and the observed data of 0.959 exceeds the critical value of 0.918, it is reasonable to conclude that the data come from a population that is normally distributed. Okay, now what we want to do is draw a box plot to check for outliers. So we're going to go back to the data, and we're going to select Graph, and now we're going to go to Box Plot. Select our column. Okay, we want to draw our boxes horizontally, and we want to include the mean. So let's go ahead and compute, and there is our box plot. Okay, so do we verify any outliers here in our box plot? Well, we don't see any outliers at all for this box plot. And so therefore, there are no outliers because there are no points that are outside of the 1.5 IQR boundaries. Okay, now in part C, what they want us to do is they want us to be able to construct and interpret a 95% confidence interval for population mean cost of repair. So we want to be able to find the mean, the standard deviation, okay, the sample size. So let's go ahead and do that by using the data that we have from StatCrunch. So we're first going to come in here, we're going to select Stat and go to Summary Stats and go to Columns. We're going to select the variable 1 for our column, and we want the mean and the standard deviation. So let's go ahead and copy that. Okay, so there's the mean and the standard deviation. So from this information, we can determine that the mean, the sample mean, is going to equal 1,757.0. We know that our sample standard deviation, we'll round it to 2 decimal places, is going to be 1,016.54. We know that our sample size, from up here, we know that our sample size is 10. And so now we need to determine what is the critical value. Okay, so again, to determine the critical value, we know that alpha is going to equal 100% minus the confidence level of 95%, which gives us 5%. And as a decimal, this becomes 0.05. Okay, so now what we want to do is now take that alpha and divide it by 2. So we're going to have t, which is 0.05, divide that by 2, which gives us 0.025. Okay, and we also know that the degrees of freedom is going to be the sample size minus 1, which is going to give us 9. Okay, so if we want to use the calculator, we can use INVT, and our area is going to be 1 minus 0.025 with the degrees of freedom to be 9. So let's go ahead and do that in our calculator to see what we get. So second distribution, we're going to go to INVT. We know we got 1 minus 0.025, and we know our degrees of freedom is going to be 9, and let's go ahead and put that into there and then press enter. And so therefore there is our critical value, or critical t value. So we're going to round that to 2 decimal places, or 3 decimal places, excuse me, which gives us 2.262. Okay, now if we wanted to use the table, okay, we're going to come down here. We know our degrees of freedom is 9. And our area is 0.025. And so you can see here that we get 2.262. Or if we wanted to use StatCrunch, then we would use the T calculator. So we would go to Stat, go to Calculators, and then scroll down to T. And we know our degrees of freedom is 9. And we know that our area to the right is 0.025. And if we compute, then because we have less than or equal to, it's given us the negative value. So we want to make sure it says greater than or equal to. Okay, and we want this area to be 0.025, and therefore it's going to give us the positive value. Okay, and then if we wanted that to be less, then it would give us the area that's to the left of that, which gives us the same critical value. Okay, so now that we know that our critical value is going to be 2.262, now we can figure out what our confidence interval is going to be. Okay, so using our formulas, and the formulas that we have, we know are the lower bound and the upper bound. So the lower bound is going to be the sample mean, which we have 1757.0. We're going to subtract the critical value, which is 2.262. And then we're multiplying that by the standard deviation of 1016.54. And then we're going to divide that by the square root of the sample size, which is 10. And so putting that in our calculator, we're going to approximately get 1030. Okay, then we want to find the upper bound. We're going to take again the sample mean and then add the critical t value times the sample standard deviation over the square root of the sample size. And so for the upper bound, we get approximately 2,484. Okay, now what does that mean? Well, what that means is that there is a 95% confidence that the population mean repair cost is going to be in between $1,030 and $2,484. Okay, now the last question says, suppose you obtain a simple random sample of size n is equal to 10 of a specific type of mini vehicle that was in a low impact collision and determine the cost of repair. Do you think a 95% confidence interval would be wider or narrower, and explain? And so here you're going to use the fact that generally a more focused sample will create narrower confidence interval to determine how the change in the experiment would likely affect the confidence interval created. So it's going to be narrower because there is less variability in the data because any variability caused by the different types of vehicles has been removed.